All right. I'm seeing some faces who are in presence of the last meeting, last talk. Welcome to the new faces. Quick show of hands. Who is new to Zephyr? Awesome. And new to embedded development? Great, you're in the right place. Who is currently working on IoT applications or wants to work on IoT applications? I should probably split that question in two halves. Who's currently working on IoT applications? And who's planning on working on IoT applications? Awesome. Well, hopefully, whether you have experience working on IoT, connected devices, or if you're looking to find a solution, you come away with this talk having a better sense that Zephyr is a good tool for your toolbox. I'm really be focusing on how IoT can be enabled more easily with Zephyr and go from there. So quick about me. I've been involved in Zephyr. I was actually looking up online since 2017, really early days, working on the Open Thread project, which is one of the subsystems within Zephyr. I'm represents Golioth, my company, and the TSE and marketing. And yeah, I'm the founder and CEO of Golioth, which is a cloud specifically built to enable Zephyr applications. So before I forget, my Twitter, you can find me on Twitter, Beri, or you can even email me. So today's all tracks are intro tracks, and that means a lot of things to a lot of people. For this talk, we're going over key topics, but I peppered it with a lot of links. This will be posted online, so it'll be made available through the Linux Foundation's website, because one of the things you'll probably walk away from this talk is there's a lot of stuff in Zephyr. It's actually really helpful, but to find the documentation or the samples takes a little navigation. So hopefully this talk will be a future guidepost. There'll be some time for questions, hopefully, if I don't drone on too long. But of course, I'll be here all week if you're in person, or I'll be hanging out in the Discord if you're online. And I guess if you're watching or recording, go find me on Twitter. All right, so kind of a trite question or a weirdly phrased one, but what is an IoT device? Giving the start of this talk. No surprise, it starts with Internet of Things. It usually means a product or a prototype that has some way to talk to the Internet. And if we're talking to a room full of embedded engineers, which we are here in person, we think about modems, things like Ethernet and Wi-Fi. But it's a lot more than that. There's a lot of complexity that goes in beyond just connecting your device, getting a socket, and running some firmware to handle data. That's just the beginning of building the IoT side, the internet side of IoT. It's also not just what I call the big internet. So we think of websites and servers, those kinds of forms of communication. We know that we're not talking about that same kind of hardware. We're also not talking about that same kind of software problems, things like protocols, things like constraint systems. It gets really complicated if you're trying to build an internet-capable device that's not talking to the big internet. And this is something I'll try to explain a little bit better, but we typically talk about internet and internet protocols and IP and think about all the use cases for serving internet traffic. But there's also IoT devices that we think of on our day-to-day lives that are not talking to the internet and also can be enabled and simplified because of the capabilities of Zephyr. So I'll explain what I mean by indirect internet. And then, of course, there's the things part of the Internet of Things. And for this talk, and for most of the conversation around Zephyr, we're talking about microcontrollers, not Marvel Universe, or at least microcontrollers are involved in some subset. You see a lot of applications that have both non-microcontrollers, but the microcontroller part could be used by Zephyr. There'll be some talks later this week showing the combination of, let's say, Cortex-A devices and microcontrollers. And generally, the IoT use cases, sensors in the world, sensing things, providing gateway-level functionality, whether that's on the networking side or local compute, and also actuators, things like door locks and robots and other things. And there's the compute part. So you got the microcontroller. It's going to be processing some of that sensor data. And some comms part, some communication. Maybe that's sending it over a serial interface or some other sort of direct connectivity. And then there's the connectivity part, so talking to that internet piece. Maybe that's sending a packet over to a Wi-Fi modem hanging off the side. Maybe that's talking to a peripheral that's on die. So that's the Internet of Things in a 5-minute ramble of what we're talking about here. And the reason why I structured this part of the section is this is what Zephyr is really good at, all these things. And hopefully we'll see that together. Let us skip aside. So it's interesting if you go on Twitter, the Twitter handle for Zephyr is Zephyr IoT. And Zephyr is good at a lot of things, including IoT, but it's also not specifically focused on, or necessarily for internet-connected devices. Because Zephyr is, trying to define what Zephyr is, but it is an RTOS. It is a real-time operating system. It is the things you need to talk to the hardware on an embedded device, especially microcontrollers. And it's all the things you would expect from an operating system, things like a kernel, things like specific OS services, things like the ability to talk to devices through abstract drivers, talking to peripherals. Even more than that, like a build system and other parts that make Zephyr a full-on ecosystem. And then there's a whole bunch of IoT bits, which don't fall into those categories, and that's what we'll be focusing on from here on out. There are lots of talks at the ZS this year, even today during the intro day, as well as other sessions that will go into other parts in very, very deep detail. But we're talking about IoT. And I try to break up this talk into 5 areas. It's almost like following the packet, if you will, where there's the device, there's the networking, there's the modem. We'll see why they're separate. The protocols that those speak, and then ultimately the security wraps it all together. And we'll kind of go through each one individually. So devices, and they separated out the internet and the things as 2 separate aspects, but it's actually really important because that's where your product design starts. It starts with the actual device that you're trying to do a bring up on. And to summarize a lot of stuff that regarding the capabilities of Zephyr, it really starts with device support. There's a lot of options out there to, you can write your own firmware, you can bring up your own chip, but out of the box, Zephyr has a lot of capabilities that you can just grab. The previous talk talked a lot about device tree and in-tree overlays for 400 specific types of boards. Those are also based on chipsets. So even if the board is not, even you're building a custom board, if your chip is supported in Zephyr, you now have thousands of combinations of just the microcontrollers you're trying to work with. So kind of check off that box. The beginning part of your IoT device is addressed with Zephyr. This one, I can't express enough how vendor support and the growing vendor support within the Zephyr ecosystem is one of its biggest differentiators. There are member companies who sponsor both dollars, so invest into the project and fund it, as well as humans, so hours of engineering time to make Zephyr better, from the silicon vendors themselves. And why that's really important, if you've never worked with a chipset at any kind of scale, the moment you have a problem, you're going to go to them because you bought the hardware from them, or your customer, or your company. And if they support the operating system and they officially support it, you're going to get help. And if they don't support that operating system, well, you're going to have a bad time kind of thing, right? And some vendors will try to, but if you're going to choose stack rank which solution, you're going to go with the vendor solution time and time again. And so by having all these vendors participate and sponsor the project, it really shows the quality of the the support is really good. There's actually also chipset vendors who are not yet members, but also are actively supporting it. For example, Espressif, a very common Wi-Fi component manufacturer. They're not members yet. Hopefully they'll join. They're watching. But they have engineers who are doing the development of the Espressif platform on Zephyr. And so you can get support through those channels. Not only is it supported by the vendors, it's also supporting the latest and greatest, which if you have older chips that maybe you can get today, actually, those are fine. But if you want to have the best peripherals and the most performance, and maybe even the drivers that take advantage of low power modes, you can only get that from the vendor. Even if it's open source, you need that maintenance, that testing, the validation, and you get that with Zephyr. And lastly, the vendors themselves are actually in the Zephyr support channel. So if you use a Nordic part and you have a very Nordic-specific problem, you might go to the Nordic Dev Zone. Great support from support engineers there. But also Nordic engineers hang out in the Zephyr Discord and mailing list. And if you have Zephyr but kind of Nordic problems, they're also jumping in there. So really good vendor support means you're going to get help when things go wrong. And hopefully you also have help so they don't go wrong in the beginning. And as going around the device, sensors. Most IoT applications, not all, but most have some form of sensing of the world, whether it's temperature or motion, magnetometer. With Zephyr, there's a built-in subsystem specifically for sensors, and it's a common sensor framework. And vendors can choose, or even community can choose, to build upon that common sensor framework, which allows, one, reuse of a lot of code. It means flexibility, so you can swap between different sensors. And if you're trying to model a system and maybe you want to have lots of sensors, it's just really easy to spin up a bunch of sensors, try it out, and then remove them without having to do sensor driver after sensor driver after sensor driver. It's a scalable design, so it's because of the framework, there's sensor families. So even if there's a sensor from one family supported but not another, it's either usually working out of the box, just because of the architecture of the framework and how most sensors are designed, or it's really easy to add it yourself, usually one line of configuration, typically. And we see a lot of community members who don't work for the sensor vendors actually upstreaming their contribution because it's just so prevalent in IoT, but also very, very easy. And there are shields, and you may be familiar with this concept from other ecosystems like daughter boards or add-ons or headers or hats or whatever. With Zephyr, they have this modular system to allow this kind of capability where you can go buy a shield from one vendor, maybe on Amazon or whatnot, and drop that in onto your board. It includes a lot of the capabilities that can be componentized and reused. And because this is part of the Zephyr RTOS, that means people are bringing shields from other, let's say Arduino shield that was coded against Arduino and working with Arduino of the library and framework, but actually making it run on Zephyr relatively easily. And so out of the box, there's a couple dozen shields already. You can even make your own shields. So as you're going through that R&D process, taking your sensors, maybe you have some power system, design a shield, manufacture it, and now your teammates can have a reusable shield component and not have to worry about, let's say, application code and sort of the sensing code. It's really useful for rapid prototyping. We see companies actually grab a shield from Amazon, use it to bring up their Zephyr development, and then quickly design it out with the proper sensor or the proper network driver or whatever. And this is kind of the beginning of my link slide. Don't worry about copying this down. Like I said, this is going to be available online. But you can kind of see there's different places, hopefully you can see, there's different places of where resources live. And this is not quite a navigation through the world of documentation and samples at Zephyr, but there's the documentation site, there's the GitHub repo, there's the website, and when you come back to this, you'll find out how to get a sense of feeling. But there's all the boards documented, all the shields, all the sensors, etc. Feel free to take a picture, but it might be easier to grab it online. So we talked about devices, now we're talking about networking. And networking is a software problem, and having worked in networking for most of my career, it's a very hard software problem. One of the two things I never want to develop in software, one is security, and the other one is networking, and thankfully you'll see why we don't have to do either. So if you look at this diagram, it hurts my eyes. It's very complicated, and this is to show you that Zephyr solves a lot of the networking problems for you out of the box. So if I can just draw, when I write an app for Zephyr, I'm just doing very little bit of application code, sometimes 50 lines or less of C. Because Zephyr's architecture has this robust, hierarchical, integrated networking stack. It was custom built and specifically designed to work well with Zephyr, and they've actually gone through several iterations to get to this point. And we'll kind of walk through these pieces, but just know that if you're trying to open a port, send an HTTP packet to somewhere on the web, it's going to be 50 lines of C, maybe less. And most of that's probably just comments, hopefully, because of the abstractions of the networking layer. So you don't have to know about any of this. But if you do need to know about this, let's say you're touching different parts of the stack, it also is also really, really great. So let's keep on going down this. So this is an example walking through a network communication. Let's see if I have not tried this in presentation mode. But all right, so again, very, very complicated workflow. Same diagram. If we look at, it's here. Let's say you're trying to do a networking application. So I'm listening for a UDP packet, and I'm going to respond to a UDP packet. So here's your, let's say, Ethernet physical device. It talks through the built-in Ethernet driver that's probably supported by some vendor using the common Ethernet framework. Then it's going through the Ethernet subsystem, which is actually pretty robust and has a lot of capabilities for monitoring, et cetera. It's then communicating into the network management layer, talking over IPv4, parsing a UDP packet, sending it through the socket interface, and all of us, and just for your 50 lines of code. And similarly, if we go to the other side of the equation, it's just as easy. That same application code is doing all the work, and Zephyr is handling the complexity underneath. The reason why I'm walking you through this is because these are pieces that you can then take advantage of if you have to. And we'll talk about that in a quick second. But besides all the networking stuff, which hopefully you're either scared about or excited about, there's advanced capabilities, which when I first learned about this in Zephyr, I thought this is as mature as what I would expect from Linux. For example, instead of just relying on your application code and the networking stack doing all that networking, if you have hardware that can do networking off device, freeing up resources, freeing up RAM, well, you can do network traffic offloading. We actually use it a lot in our products and in our examples. Or the ability to monitor your network using network health and statistics. Or packet filtering, basically a firewall on a microcontroller, which is like, mind-blowing for some. And even things like a shell. I don't know if we showed in the last talk, but Zephyr has all these powerful shells that you can just connect your UART2, start running commands, and without even writing any code, testing what's going on. So, show me the packet, what's the IP address, things you would expect from a full-blown operating system running on your tiny microcontroller. And again, all built into the networking stack. Yeah, I skipped a slide. Anyway, there's a ton of documentation on networking. 99% of applications don't even have to read any of that. All you need is the few samples related to HTTP, UDP, WebSockets, whatever you want, and you're good to go. So devices, networking, and modems. And we're following that packet, right, from the application code you wrote. It's running on that microcontroller, talking to the network stack, now communicating with that modem. So my analogy keeps on working. So when we think about IoT devices, we think about IoT internet messaging, internet protocols. And so you need some sort of device that can communicate over the internet. And classic applications include cellular, Wi-Fi, and Ethernet. And Zephyr has a lot of devices built in that you can take advantage of. Again, repeated theme, hundreds and hundreds of boards. That includes the networking connectivity options. And there's where everything from 5G cellular to modern Wi-Fi, as well as Ethernet. And that can be on device or off device. So nice combination of capabilities there. And underneath the covers, they could even be doing things like speaking SDIO. So if anyone's done off-board Wi-Fi, that's built in. If you're talking to a cellular modem over AT commands, that's also a capability nicely built in. And this is what I was trying to get at the other internet, or indirect internet. Because when you think of wearables, we think of sensors, we think of industrial controllers, they're kind of like IoT applications, but not fitting that perfect model of IP, Internet Protocol. And so things like Bluetooth, there's a lot of work being done in Bluetooth, full support for Bluetooth, actually certified stack as well, including future features of Bluetooth, 802.15.4, which is and used in technologies like Zigbee and Thread, LoRa, CAN, RS-232. Is anyone old enough to remember DB25s or DB9s? Yeah? And so we're seeing a lot of these, especially low-level forms of connectivity, these kinds of modems, being used by industrial applications, especially around the CAN and RS-45. Not just by us, but within the community of Zephyr folks. And this is what I was trying to get at. If you have to write a driver, if you have to write a implementation of a new type of modem, or you actually just bring up a particular device, there's capabilities within Zephyr in the network management layer that you can dig into. One of the features that I always talk about when I give intro talks is Zephyr's network management layer. Because if you were to go grab a kernel from another operating system and build your application, you have your threads, you have maybe your operating system abstraction layer, the moment you have to manage a network, bring up a modem, check an interface, pass sockets, most of the time you have to do that yourself. But with the design of Zephyr's network management layer, you can either take advantage of it, so you don't have to care that it's there and it's just doing all its work, or you can hook into it. So for example, if you're developing your own modem or bringing up a modem that's not supported, you can hook into it and then manage it almost like you're in a larger operating system. It's surprisingly capable while still being resource efficient. And more tons of links. I guess one of the caveats I want to say in this section in particular is the relationship between the modems and the boards, because a lot of devices within Zephyr they're in the source code, and you can see them. You can read the device trees. But the way you understand how to use them is actually in dev boards. So you go to the boards list. You'll see, like the NRF9160 development kit, the DK from Nordic. That's where you're going to read about what capabilities of the cellular modem you can use, how you can interface with it. So a lot of that documentation is hidden within the actual board-specific implementations, even if it's fully supported within the docs. And there's just a ton of stuff around networking, which hopefully you don't have to touch unless you really have to. So devices, networking modems, and protocols. I will caveat, this is one of my favorite topics. I will bore everyone here. I can talk for the next 3 hours about IoT protocols, but I won't. But it is really important, especially if your company is brand new. Maybe you don't have an existing way your device talks to the cloud or another device. And one of the things that I'm particularly involved with is the support of protocols and how to evolve that. But the theme of this talk is Zephyr will help you out here. Going back to that big internet, thinking about talking between a device over Ethernet using IP, IPv4. There's pretty good support of IPv6. HTTP, if you want to talk to a server. WebSockets, if you're trying to do anything like real time. But also some of the lower level stuff. If anyone has done DHCP, DNS, Bonjour MDNS, that's also starting to make its way into Zephyr. So you can start building more complicated applications, maybe gateways and things like that. Again, standardized protocols, part of the stack. And there's also specialized protocols. When we talk about IoT, for those who are thinking about IoT, you might hear things like MQTT, CoAP, LoRaWAN. Again, those are part of Zephyr. There's really well-supported, well-tested protocol implementations. We use them at Golioth. But also maybe more bespoke technologies like mesh networking. So Thread is an example. We actually use Thread. We'll be demoing it in our demo booth. And industrial protocols like Modbus. And there's a few more that I've been seeing under development. So from an application developer's perspective, there's a CoAP implementation. You go to the CoAP docs, you find the CoAP samples, and you just get to use CoAP. You don't have to worry about the serialization, the management of memory, the integration between the protocol side, the modem, and the networking side, because it's all batteries included. And again, links. These are also kind of muddied a little bit in the docs. It's feedback I've given already. But the networking world is very, very complicated, so there's lots and lots of good documentation, but you just kind of need to know where to find what you're looking for. Here's some pointers, but if you start digging around, you'll definitely find what you need. And the last topic is security. And just like I could spend 2 hours talking about security, I could probably spend protocols. I could probably do the same for security, but we're not going to spend too much time here. But the key thing is, if you're trying to build a secure IoT device, that could mean a lot of things. Security it's not a silver bullet. But as it relates to communication and your application, there's already a built-in functionality. So if you're trying to communicate securely between your device and a server somewhere, there's built-in TLS, secure communication. It's integrated into the IP stack. It's integrated into the networking stack. It's integrated into the protocols. So it just kind of works, which is awesome. Now, there's also configurations and flexibility. Secondly, if you're trying to build a device that's going to be connected to the internet, you probably want to make sure it's updatable. And there's a built-in bootloader. It's part of an open source project called MCU Boot, integrated into Zephyr, also integrated to the file system and other parts you need to really keep in mind. And there's even some aspects of trusted execution environments. Has anyone heard of a TE or familiar with this? So it's a secure enclave. It's making its way more and more into IoT applications. It comes more from the server world and now getting to the tiny device. If you think about if you're talking securely to a service, you might have some sensitive data. Well, do you want to run into your main thread on your main application, or do you want to put it somewhere more safe? And that's what a trusted execution environment is good for. And there is support in Zephyr already. And these are the three ones I kind of highlighted. These are actually 3 different projects. They're outside of Zephyr, but are integrated into the open source project. So Embed TLS, really good TLS library, very common. MCU Boot, which is the open source project for a secure bootloader, and Trusted Firmware M from ARM for that TE, that secure enclave. All right, so wrapping up, we went through the sort of 5 parts of building IoT device: devices, networking, modems, protocols, and security. That was a whirlwind. And we'll kind of leave it off in just a few minutes. So I hope by now you come to agree with me that Zephyr is made for IoT. There's pretty much everything you need today to build a lot of types of IoT applications. And certainly, we'll see proof of that out in the demo area. But it's also extensible. So either things you want to add or things you need to extend, there's extensions for it, or there's a path for you to go do it yourself, as well as the community of literally thousands of contributors adding new functionality to make it easier to build future IoT devices. Great vendor support, and there's lots and lots of documentation all around the project, even though it might be a little hard to find. So hopefully we can make that a little better in the future. Here are some general resources. Hopefully these are easier to see. But if you're the kind of person who starts the code, github.com/Zephyr project-RTOS/Zephyr, for the recording as well. Dig into the code. But the docs.zephyrproject.org is a lot of the resources I was sharing. It's just a wealth of information. You could spend days just kind of navigating it. There's a Discord, so a synchronous communication tool if you haven't used it before. It's a chat program. Lots of people are hanging out there in the Zephyr Discord, including maintainers, as well as contributors, as well as people in the ecosystem, including me. And if you're an asynchronous kind of person, then there's a mailing list that's also monitored, and we have great questions there. And Zephyr has an official YouTube channel. So talks, I believe, from ZDS this year are going to be on there, like last ones and other related Zephyr content. And some stuff for us. Golioth, we blog a lot about Zephyr. And so blog.golioth.io, you can find all our content, and there's a category there. We also create YouTube videos related to Zephyr, both as part of our blogs, but also just general stuff that we discover along the way, some tips and tricks, as well as how we use Zephyr, which may be helpful for you. And if you're interested in Golioth, we definitely support Zephyr, and we're a good cloud to use and integrate with. And later today, if you're in person here in Meetspace, there'll be a workshop at 3:20. Is that right? I think in this room, actually. So, or in another room, maybe. But definitely check it out if you're interested in getting hands-on with Zephyr. With that, I will leave you with, again, my Twitter and my email. So thank you very much. And how are we doing on time? Do we have any time for questions? All right. So those who raise their hand work in IoT project. Anyone working on anything today with Zephyr? And are there any challenges you're struggling with that we may be able to help with?
I think we've done some stuff mostly like coming from like the Linux side, right? So I always kind of feel like there's this, Linux can be really sort of like heavyweight, right? Like you need sort of like higher end hardware, stuff like that, right? But it does make a lot of the things you're talking about, like with the networking, much easier, right? I mean, just drivers that work for Wi-Fi, or the ability to like pull in libraries to do things like MQTT and TLS and all of that, right?
Yep.
It's always, in my opinion, it's like, you can go do IoT on MCUs, but then all that stuff gets a lot harder. So I think it's like attracting us to look at like Zephyr is sort of getting a lot of the similar things that you would get like out of a Linux environment, but coming more from microcontrollers up. Like honestly, I think it's getting like very blurry right now as to like whether you should choose an MCU for a project or like an MPU, because you've got some MCUs that are actually even like higher clock cores and like crazier feature sets than even some of the MPUs, like the low end ones these days. And it's like almost weird to be like, which is which. Like there's MCUs a lot with like off-board DRAM, off-board flash. So it's cool to see like that there's just more options out there, right? And I think Zephyr is providing a lot of that comfort of being able to pull in like well-used and developed things to where you're not like having to roll your own, right?
Yeah, the comment from the audience was, they're coming from the world of Linux, where because Linux is such a mature operating system, there's a lot of things specifically for IoT, like networking, like device drivers, that actually kind of make it easy to build, let's say, a wireless thing with a sensor on the other end. And that it classically hasn't been the case for microcontroller class devices, and that Zephyr, partially because it builds on a lot of primitives from Linux, but also learnings from Linux, is enabling it to become more possible. So it's awesome to have choice. And then the comment around, it's kind of blurring the line. Funny enough, or interesting enough, Zephyr also supports MPU class devices. There's Cortex-A, Cortex-R, RISC-V 64, x86, in-tree maintained implementation. So the line gets even blurrier, which is interesting. I think it enables some use cases that people haven't really explored yet. Oh, and also FPGAs. There's a large class of FPGA support in Zephyr. So for prototyping and things like that, becomes also interesting. All right. No questions? Everyone go build their IoT device very happily? Thanks to Zephyr. Well, thank you very much for being a great audience, and see you around the conference.